this lesson is on simplifying and multiplying radicals. When we multiply radicals, we multiply the numbers that are underneath the radicals. So when we do the square root of 2 times the square root of 5, that's the same as saying the square root of 2 times 5, which is the square root of 10. Here, when we're multiplying the square root of 3 times the square root of 7, that's like saying the square root of 3 times 7, which is the square root of 21. So that's how we multiply radicals. If you have a coefficient in front, say we had 2 square root 3 times 3 square root 7, so that's a similar problem to the one we did before. We multiply the coefficients on the outside, and then we multiply the radicals times each other. So we're going to do 2 times 3 on the outside times the square root of 3 times 7. So that would be 6 times the square root of 21. We use this information when we want to simplify square roots. When we see square roots that have large numbers, and these are not huge numbers, but we're going to start with some easier numbers so that the larger numbers are doable when we get there. When we're trying to simplify, we want to be sure we're familiar with a list of perfect squares, which I listed at the top here. 1 squared is 1, 2 squared is 4, 3 squared is 9. These are all numbers that if I asked you to take the square root of, there would be a whole number for the answer. If I said, what's the square root of 64? You would say 8. So if we want to do the square root of 20, we want to simplify this. The instructions would say simplify. Kind of like the way we simplify a fraction. We look at the list of perfect squares and say, what factors of 20 are on that list? And we see that 4 goes into 20. So we're going to break up 20 and we're going to say it is 4 times 5. Now we're going to split these apart, kind of going backwards from what we just learned. The square root of 4 times 5 is the same as saying the square root of 4 times the square root of 5. And we know that the square root of 4 is 2. And so we have 2 times the square root of 5. If we look at 5 and we want the factors of 5 are 5 and 1. If 1 is the only factor that's on our list up here, we know that we're finished. So that's 2 times the square root of 5. Now we're going to move on to the square root of 32. When we look at the square root of 32, we want to look for the numbers that are perfect squares. They go into 32, and we see 4 does, but it's often a good idea if it's one of the smaller ones to keep looking. 9 doesn't go into 32, but 16 does. I would use the larger number because that's going to simplify your process. 32 is 16 times 2. So we're going to say the square root of 32 is equal to the square root of 16 times 2. So we've just split up 32 into some of its factors. So that's the square root of 16 times the square root of 2. We just broke up that big radical into 2 smaller ones. We know the square root of 16 is 4. So it's 4 times the square root of 2. Since the only factor of 2 that's on our list of perfect squares is 1, we know we're finished. And the last one we're going to do here is the square root of 50. When we go back to our list, and we want to know which ones are factors of 50. 1 is, of course, 4 is not, 9 does not go into 50, 16 does not go into 50, 25 does. So we're going to break this up into the square root of 25, and 50 is 25 times 2. So we're going to write 25 times 2. Then we'll break that up, the square root of 25 times the square root of 2. The square root of 25 is 5. And we can't simplify the square root of 2, so 5 times the square root of 2. And that's how you simplify square roots.